This question is from 2015, mixture of friction, moment of force, and a bit of kinematics too. This question can be done using energy concepts as well, but some of you have not studied energy. Therefore, I'm going to use kinetic equations. All right, fine. First and foremost, you have to understand what's going on, and you should be able to illustrate, or you should be able to put that into a diagram. What's going to happen next? Now, this is the initial state of the. This is the initial state of the. This is the initial state of the object, and what's going to happen to it eventually. That's the question. Now let's quickly go through the question. A uniform rectangular wooden strip of length capital L, uniform, that's important, uniform, capital L. Therefore, when you say uniform, the weight is going to act exactly at the center. All right. Capital M is placed on the table along the x direction and parallel to one of its edges, so that a part of the strip is extended out of the figure like this. A part is extended out a figure. Distance from the center of gravity G of the strip to the edge of the table is x naught. So they have given this distance as x naught. So this is center of gravity. That gives me the freedom to mark the weight exactly here. This is the weight of the object. And what is the mass of the object? They might have given that capital M. Therefore, weight or force mg will be acting downwards there. And the distance to the weight from that point is going to be L by 2, isn't it? L by 2. From here, it's going to be capital L by 2. Because it's a uniform plank. It's a uniform strip for wood. So this is L by 2, L by 2. It will be equally distributed, the length on either side of the center of gravity. Now a small block of mass M is placed at the left, is placed at the left edge of the strip, and an initial velocity of V is given to it along the strip in x direction. So they are giving an initial velocity V. If the coefficient of kinetic friction between the strip and the block is mu, so there is friction involved here because they have given the kinetic friction. Mu d is actually given to us, that is mu. Mu d means a dynamic coefficient of dynamic friction or kinetic friction. The minimum speed that can be given to the block to topple the strip is. So we need to topple the strip. If the strip is toppled, we need to understand that something like this is going to happen. Now, when the strip is at the verge of toppling, what should happen? Now this is the edge, so I'll just mark the edge like this. I'm not going to draw a lot of diagram, a lot of things. I'll just mark the edge like this. This is enough. Right, this is the edge. All right, fine. And when the block has moved sufficiently, it will be at a point somewhere here. We don't know what that point, what that length is. At when the object is at this point, the strip will be at the verge of toppling. The strip will be at the verge of toppling. That means it's like this, this is the edge, and this is where the weight is acting. I have already marked. So when the strip is at the verge of toppling, this is the situation. This is how the situation is going to be. The weight will be acting mg, and this small distance is x naught, just like they have indicated in the diagram. All right. So here I say strip at the verge of toppling. Right. Fine. And there will be another weight here. It has not gone to the cornermost point. We don't know that. Okay, we don't know that. It has not gone to the cornermost point. So its weight will be acting like this mg. Its weight mg. I'll mark it in another color maybe. Right. Let's mark it in red. Okay. Mg will be acting. Simple mg. Okay. Right. So about this point, this is like the pivot now, because if the wooden strip is going to topple, it's going to topple about this. Why is that? Now, when it is going to topple, see if you can understand. When it's going to topple, this is what's going to happen, right? You can expect something like this to happen. This is the strip, and if it's going to topple, it will topple like this, like this. When it starts toppling, it will do this. That means you can see the red color mark I have kept there. That is the hinge. If not, that is the pivot actually. About that, it's going to topple. Right. So if the wooden strip is going to topple, what should happen? The clockwise movement about this point, I'll take that point as x maybe. No, not x. I'll take that point as okay. O. Okay, fine. O. About O, if the clockwise moment is larger than the anti-clockwise moment, that is when the strip is going to topple. You have to understand that. That's when the strip is going to topple. So let's say strip is at the verge of toppling. When the strip is at the verge of toppling, what's going to happen? The clockwise moment is going to be equal to the anti-clockwise moment, and I have not marked R. R is the perpendicular reaction. R is going to be 0 because the strip is at the verge of toppling. Therefore, the contact between the strip and the wooden block, table is almost 0. That R is almost 0 because that contact is almost going to be lost now. That's why I have not marked R anywhere, the perpendicular reaction. Now here I have to definitely mark R acting on the strip. But here I have not marked R because strip is at the verge of toppling. Imagine when it's at the verge of toppling, that the contact between the table and the strip is almost lost. All right, fine. So the mass started here and it has gone somewhere here. We don't know this distance. I'll take that distance as x. That is the extra distance it travels from the point. So I'll take this distance as x. Fine. That small distance is x. Okay, right. From this pivot, it has gone extra distance of x. It has not gone to the corner. Huh? Fine. Now, what should we do? So you can see there moment theory can be applied. Strip is at the verge of toppling. So you can say clockwise moment about O. Clockwise moment about O should be equal to anti-clockwise moment about O. Right, so what is the clockwise moment about O? What is the clockwise moment about O? That's going to be simple mgx. Simple mgx. And the anti-clockwise moment about O is going to be capital Mg x naught. Because from this edge, the distance to the center of gravity is given as x naught in the diagram. Right. So you can cancel this g's, g, and gone. X is an unknown. Therefore, you will get this. X equals capital Mx naught divided by M. Now I think you might be able to see this part in the answers, right? See, in this first one it's there, in the second one it's there. Fine. Now I just found that x, that is the distance. That's the distance. What distance from the pivot to the object when the strip is at the verge of toppling. Now let's get back to the question. They are asking what is the minimum speed required. So if you give the minimum speed, this box should at least come and stop here. Okay, I have given a minimum speed here. Then that box, initially the box was here, and I'll just draw it like this in broken lines. Initially the box was here and it had a speed of v. It had a speed of v, right? So we will push that here, and when it reaches here, if it's the minimum speed, then by the time it reaches here, its velocity should be 0. Why am I saying its velocity should be 0, people? It will slow down and it should come to rest here because they are asking for the minimum speed. If your speed is larger than that, the block will keep moving, going past this, and the strip will topple. Okay, here they are asking what is the minimum speed required. So you have to consider, when I give a speed, it will go cover a distance which is just enough to topple the strip. So you have to consider like that. Fine. Okay. And when the strip moves, when the mass moves like the simple m, we all know there is going to be friction acting on that, and that is going to be the kinetic friction because it initially has a velocity, it is moving, therefore it's going to experience a frictional force. Right. I'll tell you the plan now. The dynamic friction will be acting. The plan is this, people. We need to find this v. Correct? We need to find this v. For that, I know the final velocity. I know the displacement. What is the displacement, people, now? What is the displacement? Displacement. What is this length now? Can anyone tell me this length, please? What is this length? This whole length? This whole length, I'll write, see if you can understand. That whole length is going to be, until g, it is L by 2. Until g, it is L by 2. This small distance is x naught. So it's L by 2 plus x naught. That is this whole distance. And also x, an additional distance of x is moved. So altogether, the displacement of simple m is capital L by 2 plus x naught plus simple x. Look at that in the answers here. X naught, L by 2, and X is this value. Right? We are almost there. We are almost there. Right? So if you consider the object now, for the complete motion of simple limb, for the complete motion of simple limb, initial velocity is v, final velocity is 0, displacement is L by 2 plus x naught plus x. Since we have found out x, I will substitute the value. That is going to be L by 2 plus x naught plus capital M x naught over simple m. Now, I'm not going to do any change to that. You know why? That whole thing is there in the answer, people. Look at the first and third answers. The whole thing is there in the answer, right? L by 2 plus x naught plus capital M x naught over simple m. Actually, not in the third one. It's in the first one. So first one is going to be the answer, but I'll get that answer. Wait. And the acceleration part, we still don't know. If you know the acceleration, we don't know time. There's no way we can bring time here. We can find the acceleration because friction, mass, everything known. So we can apply a physical term and find the acceleration, right? And then to find the acceleration, what is the only force acting on M as the object is moving? The dynamic frictional force. All right. So let's find the dynamic frictional force for M. For M, what is the equation for dynamic frictional force? Fd is equal to mu dr. Now Fd we had to find out. Mu is mu d is mu, and r is what, people? Mg. R is mg. Right. Okay. Yeah. Here it should be mx naught over m. Thank you. Right. Yeah. Sorry. I made a mistake there. Thank you for correcting it. This one should be simple limb. Yeah. Simple limb. Yeah. Okay, fine. Now what am I doing for simple M mass? I'm applying the friction equation. R, it's mg. Why is R mg? Because it is on a flat surface, na people. So mg will be equal to R. No doubt about that. Mg will be equal to R. Then I directly substitute it. Fine. So this is the equation. Then for M, let's apply F equals ma in this direction. All right. F, what is F? Mu mg. That is the only force acting on the object. M a. So m and m will get cancelled off. Therefore, you will find the acceleration, or rather deceleration of the particle, because it's going to slow down. That will be equal to mu g. Look at the initial velocity in this direction, displacement in this direction, but acceleration is in the opposite direction, and that is equal to mu g in this. Almost there. We are almost there. What should I do now? Let's use S equal. No, V squared equals U squared plus 2AS. Why am I using that? I know the final velocity is 0. I know the initial velocity. I know the displacement. I just found out the acceleration. Final velocity is 0. What is initial velocity? V squared plus 2 into, for acceleration, you have to substitute the minus value, minus mu g, because opposite direction. We are applying the equation in this direction. S, U, all are in that direction. Minus mu g into displacement. The whole thing must be substituted. What is that? L by 2 plus x naught plus capital M x naught over simple m. Let's take this whole thing to the other side. You will be getting 2 mu g within bracket. Let's write x naught first. Okay, x naught plus L by 2 plus capital M x naught over simple m. Well, that is equal to E squared. And that's it, people. You have the answer. V is equal to square root of that. Square root of 2 mu g within brackets x naught plus L by 2 plus capital M x naught divided by simple m. So for this question, the answer is first one. So the next question is from Advanced Level 2020 paper, the latest paper, 19th question. This question deals with moment and center of gravity. So they have given us 4 rings. The combined object illustrated in the figure is formed by joining 4 metallic rings. Careful. 4 rings. A, B, C, D of radii R. So this should have the radius of R. And the large one should have the radius of 2R, not larger, the larger one. And this also should have the radius of 2R. Okay. And this one, the one bigger one, that the center will be somewhere here. And this radius should be 3R. That you have to understand. All right, these are the radii they're talking about, right? All right. The distance to the center of gravity of the combined object from point X, from this point, where will we have the center of gravity? That is the question. Okay, now how do you do that? Now, these are masses. Each ring is a mass. Each ring is a mass. Now, talking about the ring, if you consider the mass of the ring, let's see the ring, mass of the ring on which it depends. All right. So we know mass is equal to volume into density. Okay, volume into density. If not, you can take it as a mass. Mass is equal to, you can take like this, length into linear density. Let's take like that, length into linear density. What is the meaning of linear density? Mass per unit length. What is the mass of 1 meter wire? Think like that. Okay. So mass will be in kilograms, length will be in meters, linear density will be kilogram per meter, and that will be constant for all 4 rings because they are made of the same material. So linear density will be same for everyone. Therefore, you can say mass it's actually proportional to length. If not, this is constant. Therefore, I can put mass is equal to KL. Hope you understood this. Where mass, M is mass, L is the length, and K is like the linear density, something like that. Linear density. Okay, right. So what are the lengths of these rings? Now, if you take the lengths, there are 4 rings. I'll just quickly write the lengths. Hope you can relate to this. Now, A is what? 2 pi r, because it's a ring. The length of that will be the circumference of the circle, 2 pi r. And B and C are same. Their length is going to be 2 pi into 2r, and that is actually 4 pi r. And if you take D, the length of that is going to be 2 pi into 3r, because 2 pi into radius is the length of people, length. So length should be equal to 2 pi into the respective radius. And that is going to be 6 pi r. 6 pi r. All right. So if I take the mass of A as m, mass of B and C should be 2m, mass of D should be 3m. Because if 2 pi r is m, if I take that as m, this is twice that, and this is 3 times that. So first and foremost, you have to figure this out. Now, I have written all these things due to the explanation. You can do this in your head. You don't have to write all these things. You can just do it in your head. So the point is this. We have 4 masses. One will be here, that is m. The other one is here, that is 2m. The other one is exactly here, that is also 2m. The other one is exactly here, that is 3m. Why have I marked it that way? Yeah, fine. So what are the distances here, people? What are the distances? Since we have established the radii, I will get rid of them, the radii, so that I have enough space to explain this question to you. Right. Now, think of the distances to each point. What are the distances? Now, this distance is going to be m, isn't it? This distance is going to be r. Sorry, so r, simple r. This is simple r, and this is r. This is 2r. This whole thing. So I'll take it as this also r, and this one is radius is 3r for the center sphere. So it's r. This is also r, and on the other side we will have 2r. Right. So the lengths, if I mark, this will be r, 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 whereas this is 2r. This is 2r. Okay, right. Good. Now we have different points and we have to focus on those. What can we do now? What can we do now? Now, these are the 3 points. Now, forget about the rings now. Forget about the rings. Just think of each ring as a point mass. And this is how the point masses are distributed. This is how the point masses are distributed, right? Fine. So if the ring is a bit confusing, since the rings are a bit confusing, for your better understanding, I'll take everything out of that system so that we can mark everything clearly, and our working is going to be convenient. But in the exam, it's a wisest thing to do is you just finish here itself. Right, let's go. 3m is in this corner. I'll mark the corner 3m, and I'll take 2m here. What is the distance between 3m and 2m, people? That is 5r. Okay, that is 5r. 5r means 1, 2, 3. Okay, 5r, right? So 1, 2, 3, 4, 5, something like that. Okay, roughly, yeah. So 3m like that, and then 2m is at r distance from 3m. 2m, and the other one is M that is also at R distance from it. These are the points now. These are the points. Okay, these are the points. This is how the points will be distributed. If you look closely, you will be able to understand it. Right? From this M to that 2M, the distance is 3R. Right, so this distance is R, this is R, and X is important. Where X is there, it's very important because from X only we have to find the distance. So I'll mark X also, X is here. Right.